The toughest paper till now in 2026, so don't miss. Watch completely this video. Watch completely. Surely it will help for the coming exams. So 2026 22nd John morning shift. So the first question is number of unpaired electrons in low spin octahedral complex. So Mn plus 3. The atomic number is 25. So if you remove 3 electrons, you will get 3d4, which is written as 2T2Z 2 comma 1 comma 1, and Eg will be 0 because it is low spin complex, which means the ligand is strong field. That's why 3d4 to T2Z4 Eg 0. So how many unpaired electrons are there, students? 2 unpaired electrons according to Hund's rule. So similarly Cr plus 3, here the configuration is 3d3. So here also strong field ligand, so that all the 3 electrons are unpaired. Eg will be 0 and 0. So you can write 0 0. So accordingly we will get here 3 unpaired electrons. Similarly Fe3 plus, so 26 atomic number, resultant after removing 5 electrons you will get 3d5. So here you will get T2Z 2 comma 2 comma 1, Eg will be 0 0. Why? Because here also according to Hund's rule we can get 1 unpaired electron. The last ion is cobalt plus 3. So here 3d6 is the resultant configuration. So here T2Z 2 comma 2 comma 2, Eg will be 0 0. So total unpaired electrons 0 in this. Accordingly we can select the answer is, which is having, so the number of unpaired electrons in low spin complexes. So accordingly the option is Cr plus 3 is greater than Mn plus 3, because Cr plus 3 have 3 unpaired electrons, Mn is 2, this is 1, this is 0. So coming to the second question. So 4 elements from second period given, that is boron to oxygen, have the following ionization energy values. So just the value of first ionization energy of nitrogen we have to calculate. So in this case IE1 values depends on electronic configuration and also size or effective nuclear charge. So in the normal condition, from left to right IE values will increase, that to first IE1 values. But in case of nitrogen and oxygen, nitrogen have half filled configuration 2s2 2p3. So due to half filled configuration or symmetrical distribution of electrons, IE1 value of nitrogen greater than the IE1 value of oxygen. But in case of IE2 it will be reverse. So accordingly, so this one. And in carbon and boron, if you take, carbon is having more than boron, because it's normal from left to right it will increase. So accordingly answer will be, so the answer is 1402. Coming to next. An element of P block forms a specific type EH4 plus, which when we pass it through basic solution of this one, this is called as Nusselt's reagent. It is used to find the NH4 plus ion and forms brown precipitate, which is called as Millin's base. So finally you can directly also find the answer. So element has 5 valency, nitrogen maximum covalency or valency is 4, so it cannot be more than 4, and brown precipitate formed is HCO, Hg, NH2. So this will be, so they are asking select the correct option. So correct option will be second option only, right? This is Millin's base, that is with NH4 plus ion. So this is everyone knows, because this is the first thing in lab. So NH4 plus is the answer. So accordingly second option is the answer, students. Coming to next. Which of the following choose the correct answer? AgNH3 2 plus. So this one, what you can see, AgNH3 plus is Tollens reagent, right? It is used to determine or separate aldehyde and ketones, and there are many uses for that. And zinc amalgam, and this is used as Clemmensen reducing agent, and this one is Wolff-Kishner reduction. This is Clemmensen reduction, and this is Wolff-Kishner reduction, and this will be Fallin solution. So accordingly answer you can identify. That's very basic question. An element X of P block forms a hydride HX. So we have to see the an element X of P block forms HX, means X may be fluorine, chlorine, bromine, iodine, which has the longest bond length. Then the element X will have the shortest covalent radius, which is wrong, right? Because X here can take it as iodine, because HX wise HI is having more bond length than the remaining compounds. So HBr, HCl and HF. So this is the order of bond length. So indirectly X indicates iodine. So iodine is bigger in size, covalent radius is not shorter. So that's why this statement is wrong, students. Coming to next, an element E of group 15 forms hydride EH3 that has the least boiling point. The maximum covalency of E is 4. So which is wrong, right? Because least boiling point is for pH3. So the covalency of phosphorus will be 5, not 4, students. So the answer is both are wrong options. So accordingly, so this is the answer. So coming to next, so in this case they have given CH3Br reacts with nucleophile in CH3OH solvent. The correct order of rate of reaction for the given nucleophiles is, so here I minus, F minus, C2H5O minus, PHO minus. Just we need to understand this. Nucleophilicity decrease from left to right in polar protic solvent, and increase from top to bottom, which means I minus greater than, Br minus greater than, Cl minus greater than, F minus. Accordingly, carbon onwards, if you take carbon compounds greater than nitrogen, oxygen and halogens. So based on this logic, we can see what is the answer. In this case, C2H5O minus and PHO minus. Here why they given CH3OH, it is polar protic solvent. So C2H5O minus and PHO minus, if you take, generally resonance increases, nucleophilicity decreases, students, because the negative charge involved more in the resonance instead of giving to the carbon. So resonance is inversely proportional to nucleophilicity. Nucleophilicity means that tendency or capacity to give electrons to the carbon. So resonance is more in this case, because PHO minus means phenoxide ion. It make resonance with benzene ring. That's why here negative charge is not easily available as comparatively C2H5O minus. So accordingly, what we can conclude is, so what we can answer is, so PHO minus, I minus, right? First I minus greater than C2H5O minus and PHO minus and F minus. So accordingly, we can find the option is 3. Coming to next, compare the rate of SN1 reaction for the following compounds. So here SN following compounds not given. So just I am writing here. So over this 2 carbons are there, Br, this is P and this is Q, and PH, Br, this is next C, and PH, Me and Br. So SN1 reactivity order means you just remove Br and put positive charge. Accordingly, we can see where this positive charge or carbocation get stability easily. So everywhere we are taking phenyl ring, students. Phenyl ring in the sense what, where double bonds are present inside the ring, as like this. So more the phenyl groups, more the resonance or more plus R effect. So when plus R increases means the connecting conjugation increases, stability of carbocation increases. So in this C option, more number of pH groups are there, so that more stability we can find for this. But in this case, only 2 pH groups, one is methyl group. So comparatively, third option, fourth option have less stability of carbocation. So answer is, so S greater than, this is P, Q, R, S. So S greater than, R greater than, Q greater than P. So the last, this one is Bent's rule based. So bridged carbocation stability wise, we can decide the answer Q greater than P, students. So 11th one, give the statement, phenol reacts with chloroform and KOH, gives major and minor product. So that's very important and basic reaction. What is the name of this reaction? Remer-Tiemann reaction. So phenol in presence of chloroform and KOH, we get ortho and para nitrophenol. So ortho is more stable due to intramolecular hydrogen bonding, but para is having intermolecular hydrogen bonding. So volatile nature wise, if you see, this is more volatile because of intramolecular hydrogen bonding. Since it is more volatile, it is easily go with steam, so that with steam distillation, orthonitrophenol and paranitrophenol can be separated. So ortho-paranitrophenol, in that case, this is major product, this is minor product. Everywhere we tell para is major, but in this case ortho is major, students, due to intramolecular hydrogen bonding. And also it is steam volatile, para is not steam volatile. So hope it is clear. So that's the reason both statement 1 and statement 2 are correct. So these are the questions. Coming to next. So two elements of P block form halides XFE3 and YFE3. XFE3 act as Lewis acid while YFE3 act as Lewis base. So here Lewis acid and Lewis base mainly depends on the capacity to donate electrons. So accordingly, how to decide the answer. Here P block halide XFE3 and YFE3. So XFE3, the hybridization of XFE3. So this is little common sense wise we have to do this, because the question is a little bigger. It is Lewis base, then the hybridization of X and Y. So here XFE3 is BF3 we can take, because that itself Lewis acid, and the other one is YFE3 which is NH3. So these two, this behaves as Lewis base due to presence of lone pair, and BF3 have one empty orbital in its outermost shell because it has 6 electrons in its outermost shell. So it is acting as a Lewis acid. So it is having empty orbital, it is having lone pair, so that it is Lewis base, this is Lewis acid. Now accordingly hybridization, if you want, boron is having total 3 electrons in its outermost shell, and fluorine. So how many hybrid orbitals are there, students? 3 hybrid orbitals, so that sp2 hybridization. But in this case total 5 electrons including lone pair of nitrogen, and 3 are bonded with hydrogen as like this, and this will be 1 hybrid orbital. So total how much you will get? sp3 hybridization. If anyone need tricks or any other related about finding hybridization, you can listen here, you can watch complete video, students. Hope it is clear. So answer will be Lewis acid is sp2, Lewis base is sp3. So hope this is the answer. Coming to next. So an element, you can see an element M does not evolve H2 gas on treatment with dilute HCl, MsO4 1 mole on treatment with excess KCN to form a compound P. The amount of Ms formed when H2S gas is passed through compound P. So what is the answer for this? Just you can see here. Copper over dilute HCl, we get some Y compound. So here CuSO4, here they mentioned MsO4, right? Treatment with excess KCN. So this is a very important reaction. CuCN twice will be formed as like this. So the CuCN, sorry, not twice, 4 times it will be, because coordination number of copper maximum 4 over H2S gas. So through compound P, this is P, this is metal M. So there will be no sulfide precipitate here, because copper is in the coordination compound form. So no sulfide means no precipitate is formed. So that's why answer will be 0. This is important model. Coming to next. Consider the structure of HNO3 as shown here. Select the correct option having formal charge of the compound. So the compound is this. So compound is as like this. In double bond O and O. So this is HNO3. This is coordinate covalent bond. So total 6 electrons, and there will be no electrons over this, and there is a bond pairs, and these are lone pairs. Wherever oxygen is with double bond, you no need to calculate again formal charge, directly you can write 0. However it is, I will discuss. So this is third oxygen, this is fourth atom, so fourth atom, this will be first, this is second. So here formal charge formula is formal charge equals to valence electrons minus half into bonding electrons minus non-bonding electrons. So this is the formula, students. So just you can comment how this paper is it easy or difficult, or if you need any specific topic help, you can also message so that I can upload related videos. So valence electrons, just I am first finding first oxygen, first atom. So total valence electrons are 6 because it belongs to 6th group, and half into bonding electrons are how many, just 2 into 2 minus non-bonding electrons means this all pair of electrons, so 6. So what you will get is just minus 1 you will get. So here total 6 minus 7, which is equals to minus 1. Similarly you can write second atom, second oxygen atom. So 6 minus, so bonding electrons are here 4 by 2 minus, so here 4, so 6 minus, so 6 minus 6 equals to 0. Or wherever oxygen is with double bond, hydrogen is with single bond, just valence if it is satisfied, the formal charge will be 0 always. Here also oxygen is with 2 bonds, this side one, so that the third atom also having formal charge value will be, so 6 minus 4 by 2, this side that side both bonds if you take, you will get. So here also 0 is the answer. And coming to last, nitrogen atom. So nitrogen is having, so here 5 minus 10 by 1 2 3 sorry 8 by 2, 8 by 2 minus, so what is the resultant, so it will be 5 electrons, right, sorry 0 electrons. So what you will get is, so 5 minus 4 equals to 1. So accordingly here actually charge of nitrogen is +1, students. Okay, so that's what this question. Coming to next, and this is find the temperature in kelvins, which the rate constant equals to, so rate constant, so they are asking, just you can read the question so that you get clarity. So in this case they have given A to B is, this is one reaction, so K value is given 10 power 4 e power minus 24,000 by T, and same way this is other equation. Now how to do is, just we have to equate these two things. What they are asking, find the temperature at which the rate constant are equal. So this K1 equals to K2 means accordingly we have to find temperature. So 10 power 4 e power minus 24,000 by T equals to 10 power 6 e power minus 30,000 by T. So just if you equate these two things, so what you will get, e power 6,000 because we have to subtract e2 minus e1, so 6,000 by T, which is equals to 10 power 6, sorry, so here 10 power 4 is there, here 10 power 6 is there, so you can equate to 100. So 6,000 by T equals to 2 ln 10. If you send the other side it will be ln, so ln 10. So T equals to 6,000 by 2 into 2 into 2 into 2.303, which can be written as just 6,006 into 10 power 3 by 4 into 303. So it's approximately temperature is 1300. So nearest integer is 13303. So this is one of the question. So just what we have to do is we have to equate, later we are simplifying this to get the temperature. That's all. And coming to next, for an ideal gas, volume increased 8 times and temperature is decreased 4 times. if heat is exchanged during the process, so the correct gas will be. So here will be, we have to find gamma value to decide the, it is adiabatic process, right? Q equals to 0 means adiabatic process. So adiabatic process, there will be three formulas: PV power gamma equals to constant, TV power gamma minus 1 equals to constant. So based on that we are doing here. So formula for this is the concept related to adiabatic process. So TV power gamma minus 1. So at two conditions, if you take T1 V1 gamma minus 1 equals to T2 V2 gamma minus 1. So you can simplify this. So T1 by T2 equals to V2 by V1 whole power gamma minus 1. So accordingly 4 equals to 8 into gamma minus 1. After simplifying this, 2 equals to 3 into gamma minus 1. So gamma equals to what? 5 by 3. So 5 by 3 gamma means Poisson ratio is Cp by Cv. So accordingly we can find the 5 by 3 for which gas? Helium. So monoatomic gas. So that's the answer for this, students. Just we are simplifying with respect to formulas, nothing else. Finding gamma, later deciding which kind of gas it is. So coming to next question. So this is the reaction. Just you can read reaction. Reaction looks bigger. So the compound, an organic compound with molecular formula C8H9NO reacts with KOH Pr to form P, and which are on diazotization form Q. So this NO with KOH and NO, this is called as what? Hofmann degradation process or a Hofmann bromide reaction, which on diazotization form Q. Compound Q on reaction with CuCN gives R, which on acidic hydrolysis gives S. So one by one we can discuss. So this will be amide. Amide becomes amine with KOH and Br2. So C8H9NO. So in this case, if you use degree of unsaturation or DOU formula, you will get 5 degree of unsaturation. 5 means benzene is having 4 degree of unsaturation because 3 pi bonds, 1 ring, and accordingly the matching formula for this will be this one, CONH2. So for this, if you add KOH and Br2, what you will get is just methyl NH2, because CO becomes this. We did many times, last 3 papers almost having same kind of question. So if anyone don't know, you can watch complete video very clearly, neatly. All the possibilities I have explained with the work of reagent and mechanisms, everything. So don't miss that video. So CH3 NH2 you will get. So after this, what you will get is just until P we have got, which is P, which on diazotization form Q. Diazotization means NaNO2 plus HCl. So this together will give what? Benzene diazonium chloride. So whatever the NH2 is there, that becomes N2 plus X minus. So until here we have got, which is Q, and this over CuCN, this is called as Sand-Meyer reaction. So cyanobenzene is formed, which is cyanobenzene CH3CN. This cyanobenzene over hydrolysis we get CN over complete hydrolysis becomes COOH. Over partial hydrolysis it will give CONH2, means amide will be formed. But they didn't mention, so we are taking complete hydrolysis and get methyl benzoic acid, which is this one. So until here we have got, so which is nothing but S, students. Compound S on reaction with KMNO4 forms T, which has 2 type of hydrogens. So just that what they are saying is, so this reactant, whichever is taken initially, that reactant over complete hydrolysis we will get this. So what is the result? The answer will be methyl benzoic acid. So accordingly we can find the answer. So options are there. So what is the reactant? This over complete hydrolysis we will get this one only, because CONH2 becomes COOH. It's derivative of carboxylic acid. Over hydrolysis get carboxylic acid. So that's how we can conclude the product is benzonamide, methyl benzonamide. So answer for this question is this one. So CH3 CONH2. So two type of hydrogens if you want. This is primary hydrogens. These all categories remain same. So that's why two type of hydrogens present in the reactant. Otherwise this compound is having two type of hydrogens. So this is one category hydrogens over benzene ring, same category hydrogens. Coming to next. So which of the following compound P and Q shown? So here we have to know the compounds. So P is this one, chlorohexane, cyclohexane, and this is chlorobenzene. So in this case, where partial double bond character, first you can see one by one. Q has more gamma on chlorine than P. Q has more dipole moment than P. So that is wrong, right? So Q has, this option is not clear. So Q has more dipole moment than P. So this is P, this is Q. So that's not correct, right? Q is having less dipole moment than P because of resonance. So the all electrons, due to resonance, the polarity decreases between C and Cl, so that Q doesn't have more dipole moment value. In Q, CCl bond has double bond character. Yes, that is correct, right? Due to partial double bond character, SN reactions are less. And in Q, Cl attached to sp2 hybridized carbon, but in P, Cl attached to sp3 carbon. That's very basic point and correct also. And in case of Q, the CCl bond length is more due to repulsions between lone pair of electrons and pi electrons of aromatic ring, which is wrong. So due to resonance, bond length will decrease. So answer for this will be C and D options are correct. So coming to the next, some more questions are given students here. First I will discuss those. The questions are sucrose over hydrolysis. Sucrose, just statement type these questions. Sucrose over hydrolysis, what are the products? Glucose plus fructose. This is basically inversion of cane sugar. That means the resultant optical rotation is LEVO, and this one is dextro. This is resultant is LEVO. The sum of these two value is still LEVO form. So that, sorry, this is not LEVO, this is dextro. Dextro converted into resultant value is LEVO. So that dextro converted into LEVO over hydrolysis. So it is called as inversion of cane sugar. So that's the answer. So both statements are correct. First statement is given like this: sucrose is dextrorotatory. Upon hydrolysis, it becomes levorotatory. Yeah, which is correct. Sucrose on hydrolysis gives glucose and fructose, such that the levorotation of glucose is more than dextrorotatory of fructose, which is wrong, because glucose is dextrorotatory, fructose is levorotatory. So levo is more, negative value is more, so that resultant is levorotatory. Coming to last question. So here percentage of iodine based also there is a question. So percentage based means here just one more question I will give you. PCO2, log PCO2 versus log XCO2. So PCO2 is partial pressure of CO2, XCO2 is mole fraction of CO2. They are just asking graph related to this. So they have given log P versus log X mole fraction, chi, which is nothing but, so PCO2 equals to KH into XCO2. So log PCO2 equals to log KH plus log KCO2. So this is equals to y plus C plus mx form. So straight line from the origin. Sorry, not from the origin, straight line. So how the graph will be? Log piston P versus log XCO2 like this with intercept, because this is also there, right? So log KH. So positive slope. So this is one of the question related to this, and the same way they given one more question. That's all, students. Thank you. It will help for the coming exams. Thank you.